This session is going to be about Redis on Google Cloud Platform. The speakers are Gopal from Google Cloud, is a product manager, and Karthi is a solution architect with Google Cloud as well. So the stage is yours.
Cool. Can you guys hear me at the back? Okay, cool. Thank you for being here. We are super excited to be here at RedisConf and with the Redis community in general. Today we want to talk about Redis on Google Cloud Platform. Before I get started, just a quick show of hands. Who's using Google Cloud Platform here? Oh, quite a few. Okay. Who's planning to use Google Cloud Platform? So we have three things to kind of talk about today. One is I just want to quickly give you an overview of where we are with Google Cloud. We've been doing some exciting things, and we are super excited as to where we are today and where we are going. So I want to briefly touch upon some of the things that we've been doing on the cloud platform in general. But mainly, we want to talk about what we are offering as a managed Redis service on Google Cloud. And lastly, we kind of wanted to also kind of talk about one of the key things that we provide on Google Cloud Platform is to get better insights of data. So along with Redis and other GCP services, we just want to talk about how you can do that. So like I mentioned earlier, Google Cloud Platform, we're getting a lot of momentum in terms of customers, right? And there are, customers come to Google Cloud Platform for a few different reasons. One of the main reasons that customers have been moving to the cloud platform is because from our infrastructure perspective, Google has been doing this for 15 years, and we are starting to expose those massive Google scale infrastructure to the customers in general. And as part of that, we are able to provide infrastructure at a very low cost. One of the things that we see is that we are probably around 60% cheaper in infrastructure than in general. The other key thing that customers are moving to Google Cloud Platform for is insights into data, right? Google has been, internally, Google has been doing data processing and data and analytics for a long time, and we have been building a lot of these internal solutions that we are now providing in the cloud platform that customers can leverage and get more insights into the data. But there are three things that we are fundamentally focusing on. One is security, networking, and infrastructure. The second is allowing customers to unlock their data and basically get insights into the data to drive business value, and accelerate development of applications, make it easier for customers to build applications on Google Cloud Platform. And thirdly, which is probably more closer to what we are talking about here today, is being open and enterprise friendly. So I'll quickly touch upon these before I jump into the Redis conversation. So from a security and infrastructure perspective, we pride ourselves in terms of making our infrastructure super secure. And one of the key things and our differentiator that we have is that internally, when we look at Google's network, and Google's scale of network is actually pretty immense, right? We essentially use all the Google services that like Gmail or YouTube essentially use all the internal Google networks. By default, we essentially encrypt all the bits that go into the network. So it's a very secure environment that we build in terms of Google Cloud Platform. The other things that we want to make sure that the data is secure when you host your applications in Google Cloud. So we provide ability to manage your own keys in the Google Cloud Platform and make it a really, really secure environment. From an infrastructure perspective, the other thing, I'm talking about investments, and we've been aggressively expanding the regions that we are currently in. As you can see, we are currently in 15 regions, and we are going to expand to 4 additional regions in 2018. So the key point here is that we are investing a lot in infrastructure, and in the last 3 years we have spent about tens of billions of dollars in Google Cloud Platform. So that kind of shows you the amount of investment that we are making and the growth that we are expecting in the Google Cloud Platform. Secondly, unlocking data and accelerating development. So this is one of the key things that we really, really focus on, and we provide a portfolio of services. Whether you're doing real-time streaming analytics or whether you want to do like managed Hadoop, and more importantly, data warehouse in the cloud. All right, we have a portfolio of products that essentially came internally from Google. For if you look at BigQuery, it essentially came from Dremel, right? So we are exposing all these highly scalable infrastructure and services that Google internally use to the Google Cloud Platform so that you can leverage it. We're going to talk more about this, and Karthi is actually going to talk more about how you can actually use these services to get better insights into data. But this is one of the key investments that we make, and we are making in the cloud platform in general. The other quick thing that I want to touch upon is that there's a lot of buzz around serverless architectures. Google, in a way, started serverless architecture back from the time when App Engine actually came along, which was like 8 to 10 years back. And we are continuing to invest in that serverless architecture platform. So Google App Engine, Cloud Functions, Kubernetes, and all these are compute platforms that you can leverage to run your applications at scale. This is something that is very close to our heart, right? Open and enterprise friendly. Google prides ourselves in making the platform open. So what that means is that if you have something running on-prem, and if you want to just move it over to Google Cloud Platform, and if you're using open protocols, we want to make it extremely easy for you to do that, right? At the same time, if you think that, hey, you're not happy with Google Cloud Platform, it should be very easy for you to take that application and move somewhere else. That means we have to be able to support open protocols and allow you to just lift and shift your applications. So this is something that we continuously invest in. That's the reason we open source things like TensorFlow, so that you can, we build our infrastructure using open source code, right? So in line with that, one of the things that we've been doing over the past year or so, or a couple of years, is investing heavily in open source databases. Now, DB Engine's ranking is one of those popular rankings for all the different database engines out there. And if you look at all the different databases like MySQL, PostgreSQL, Elasticsearch, Redis, Cassandra, etc., in the Google Cloud Platform, you can actually build applications on any of these databases. So Google provides their own services, like managed services that they build, and we partner heavily with companies like Elastic Cloud and Mongo and DataStax to provide their solution on Google Cloud Platform. So we have a strong partner ecosystem on top of the services that we provide. So in Google Cloud today, you have Cloud SQL, which is essentially our Postgres and MySQL managed service. We also have Cloud Bigtable, which has the HBase APIs on top. Cloud Bigtable obviously is a highly scalable database that Google built internally that is currently available for you guys to use, but you can use the HBase API on top of that. That brings us to Redis. So Redis is, as you all know, is one of the most popular databases or key value stores or data structure stores, however you want to call it, in the industry today. In Google Cloud today, we partner very closely with Redis Labs, and Redis Labs is one of our closest partners. We have a lot of customers actually using Redis Labs on Google Cloud Platform. And customers are super successful, and we partner very closely with them. We also have other partners like Avon that you can actually provision services from other partners like Avon and Google Cloud Platform. But one of the things that we've been hearing from customers is that having a strong partner ecosystem is super, super important, but it's also important to have services that Google provides that is supported by Google, the famed SREs of Google, who basically manages the infrastructure and the support that comes with it. That's something that customers have been asking for a long time. So I'm super happy to announce that we have Cloud Memory Store, which we are actually announcing today at RedisConf. And Cloud Memory Store is going to be our fully managed in-memory data store service, and we are starting off with Redis. So today we are making that announcement, and the beta will be available publicly in a couple of weeks on May 9th. So what I want to do today for the rest of the session is to just give you an insight into what Memory Store is and what we are building and what we're going to provide going forward. So what is Memory Store for Redis? It's essentially Redis managed by Google. We are using open source Redis, so that means it's fully protocol compatible. So if you have applications running on Redis anywhere today using open source Redis, you can easily lift and shift that into using managed Redis so that you don't have to manage Redis yourself. It's a highly available Redis instance. So we are This is a version 1 of the product, so we will continue to build out the different flavors of Redis. So what we have today, and I'll talk more about that, is we have high availability, highly available Redis, and we actually will provide an SLA. So we will have 3 nines of SLAs to start off with for the highly available Redis instance. So what that means is that you can be guaranteed a certain level of availability compared to when you don't have SLAs for the service. We also, it's a very scalable service, and I'll talk more about in terms of what that scaling looks like. One of the key things that I do want to mention is that Redis have typically you don't want to put Redis on the internet. So in Cloud Memory Store, it's basically using a virtual private network, and we are using private IPs. So your Redis instances are protected from the internet. And we also have role-based access controls on top of that, so you can have additional protection for your instances, along with the encryption that I talked about earlier, which you get for free because of the Google infrastructure. Okay, so let me dive into a little bit more in terms of how we are offering the service. We are offering the service in 2 tiers to start off with. The basic tier is essentially a standalone instance of Redis. And standard tier is our replicated instance of Redis. So the basic tier, the key thing there is that we do all the health monitoring, recovery, et cetera, so that you don't have to worry about managing that instance. There's no SLA associated with basic tier, but with standard tier, like I mentioned, you get 3 nines of availability. For standard tier, we have cross-zone replication, so that in case there is a zone failure, we will automatically fail over the replica over to the other zone. And we take care of all the automatic failover, health monitoring, management, et cetera. The other interesting aspect about Memory Store is that we allow you to provision any size, right? So you can start off with 1 gig up to 300 gig at 1 gigabyte increment, so that you don't have to have fixed sizes that you have to provision. You can pick and choose whatever size of the data set that you want. And the way we have tiered the service is that the more at the higher memory size, you get higher bandwidths. So that's essentially how the service is tiered. In terms of pricing, we have you can provision a Redis instance in these different tiers. From a pricing perspective, as you provision more, we're about 1.6 cents per gigabyte. So we are very competitive in terms of the price for the Redis for the service itself. Basic tier and standard tier obviously have 2 different prices. The thing here is that when you provision, and I'll walk through the demo, you really don't have to figure out what kind of CPU, et cetera. You don't have to kind of size your machines. You kind of have to figure out what the performance characteristics are that you need for your application, and you can provision the corresponding instance size. We have very simple provisioning model, and I'll walk you through the demo, but you can provision the Redis instance either from the Google Cloud Console, which I'll demonstrate. We also have command line that you can use, gcloud SDKs, and we also have client libraries. So if you want to basically build any kind of workflows using our admin APIs, we have client libraries in all these major 7 languages that you can use to do that. From a high availability architecture perspective, I just want to point out, I talked about cross-zone protection from zone failures. But the other thing I also want to mention is that the instance is behind a virtual IP. So from an application perspective, you connect to a single IP. In case of failover, you don't have to worry about managing the connection. You just you retry the application, and you'll automatically be connected to the new master. So from a connection management perspective, we have simplified that, and we take care of all basically virtualizing the endpoint for you. In terms of failover, we have optimized our failover, and we have very good failover times. It should be less than a minute, or I would say probably around 30 seconds is typically what our failover times are. So in case there is a failure, your Redis instance will recover pretty quickly. Some other features that I want to quickly talk about. So in the V1 version, we will allow you to scale your instances. So what that means is that if you have a standard tier provision, which is a highly available instance, and if you want to scale your memory size, you can do that with very little application downtime. So our scaling essentially uses a rolling upgrade model. So that means your applications are online for that brief amount of time where we have to fade over from the current master to the replica. So your applications can be highly available when you do the scaling. The other key thing that we provide is monitoring with Stackdriver. So we have all the Redis metrics available in Stackdriver. If you use Stackdriver as your monitoring platform, you can easily see all your Redis metrics in Stackdriver and use dashboards to view the information. The backing up of data. So one of the things that we don't provide currently is we don't support AOF. We do allow you to take a backup to a GCS bucket. GCS is our Google Cloud Storage. So you can take a backup of a Redis instance and take an RDB backup into a GCS bucket. You can restore it back from a GCS bucket. We currently do not support AOF, but it's something that we are looking into the future. And in terms of the protocol compatibility, like I mentioned earlier, we provide full protocol compatibility. It's essentially open source Redis. There are a few admin commands that we block because it's a managed service. Other than that, from an application perspective, we are fully protocol compatible. We support Lua scripts. So if you're using Lua scripts in Redis, you can seamlessly migrate over that to memory store. And lastly, before I get into the demo, like I mentioned earlier, one of the key things that we are trying to make sure is that, recently we had that issue with Memcache where there was a DDoS attack that literally, took out half the internet. So one of the key things that we do is we ensure that Redis is not exposed to the internet. So everything is within Google Cloud using virtual private network and using private IP. So that means it's pretty secure. On top of that, Cloud Identity Access Management essentially provides role-based access. So we have Redis Cloud or memory store specific roles that you can use to limit access to the Redis instance. So that's kind of the starting point for Cloud Memory Store. We are going to be continuing to invest in the service as we go forward, and we will be providing a lot of the features that I talked about will be coming soon after we go GA. But quick question in terms of the usage of Redis in this group, do you use it primarily as a cache, or are there people using it as a persistent store? Is it majority using it as a cache? Okay. So one of the things that we are looking into is using replication as one of the persistence mechanisms. That's one of the reasons we haven't. We intentionally chose not to provide AOF as an option. We have gotten feedback from the community saying AOF is actually, from a performance perspective, it is actually pretty. It takes a big performance hit. So if you require any level of persistence or availability of the data, then standard tier will actually provide you with a copy that you can essentially use as a persistent copy. Okay, so any questions about what I just talked about?
A couple questions. So question number one, when you have this master replication in different zones, is it agnostic for application? Let's say if I have application in zone A and it talks to Redis in zone A, and for some reason zone A, Redis in zone A dies, you have a replica in zone B. Am I hit with A-B traffic cost in this case?
That's a very good question. So I think just to repeat the question is if you have a standard tier Redis instance, which is, let's take a region like US Central. So there's one in US Central 1A and US Central 1B are the replicas. And if you're connecting from, your clients are in zone 1A and connecting to master in zone 1A, so that's intra-zone traffic. So the question is, if a failover happens, will there be cost in terms of the cross-zone traffic? So the answer is, there is no cost from a Redis perspective in terms of ingress or egress. So we don't charge any networking cost for ingress or egress. On the GCE side of the world, like if your applications are on GCE, you will get charged the cross-zone network traffic from your application on the GCE side, but not on the memory store side.
Okay, question number 2. So the Redis, is it full Redis? And I'm interested in script support.
Yes, so, and I'll walk you through that. So the version 1, we are supporting Redis 3.2, and we do support Lua scripts. I think that's what you're asking. Yes, we do.
Do you have any ability to scale out, like shard the data for me? 300 gigs is pretty good, but maybe I need more.
Yeah, so that's where the roadmap conversation comes in. Like I said, we're just starting off with the basic and standard tier, and we are actively working on providing Redis cluster, which will be coming soon. But for the version 1, we will have standalone and replicated.
Is it possible to have your Redis managed instance operate as a slave initially so that it can pull data from an existing Redis in real time and have a pretty easy transition over to new instance?
Can you repeat the question? Sorry, the scenario?
If I spin up Google Cloud Managed Redis, can I have that connect as a slave to an existing set of Redis instances that I have so that it can have all of the data of that and I can then just point to a new IP address and transition seamlessly?
Yeah, so today our replica is essentially used exclusively for high availability. So we haven't enabled that yet. So the question then becomes, looks like you basically want to do a real-time sync of the data, and import-export probably is not the ideal scenario to move data. I think that's essentially the scenario you're talking about. Yeah, so we haven't enabled that, at least in V1.
And for the backup to a cloud storage bucket, how frequently can I do that? What's the granularity of how
So the initial version, it's essentially a manual backup, right? So you can basically schedule your own backup intervals. We plan to provide managed backups, and at that time we will have different increments of backups that you can take. But initially, we have APIs that you can use to essentially take that backup from Redis.
Hi, this is Balaji. Can you explain a little more about the scalability, how you manage it?
Specifically around?
I would like to know about how it auto-scale based on the number of connection, or how it can be increased by the size requirement or eviction rate or something.
So let me go back to the slide that I showed you about the capacity tiering. So there's no sharding, right? So your writes and reads always go to a single instance. In the case of standard tier, obviously we support failover, but even then, all the writes and reads are going to a single instance. In terms of scalability numbers, in terms of client connections, we will support up to 65,000 connections per instance. And we don't really tier that, right? Regardless of whether it's basic or standard, you get that. The key thing for you to note here is, in terms of the constraint is going to be on the network bandwidth side. So at lower memory sizes, if you feel like the network bandwidth is what is causing you the bottleneck, you can scale up the instance. And when you do the scaling up, you essentially, and I'll demonstrate how we do that, it's essentially just changing the memory size to a tier that will actually support your network bandwidth. And the scaling characteristic, like I mentioned earlier, for basic, essentially we will flush the entire cache, which is the standalone instance, we will flush the entire cache and just recreate it. But in the case of standard, we actually provide a highly available scaling model where your applications stay connected except for the time when we actually do the failover once the scaling is complete. So there is no horizontal scaling, you can vertically scale as needed. Does that answer your question?
I have a question on the performance that regarding to the tier. Like if I have a bigger data set, does the performance change? I mean,
Yeah, so I think so Redis obviously today is single-threaded, right? I think there are two aspects in terms of performance that can potentially be a bottleneck from the infrastructure side, and also depending on the queries, et cetera. But primarily, whether it's CPU bottlenecked or network bottlenecked. So at the higher tiers, you basically, we have about 8 vCPUs. That's what we have behind the scenes, and you have about 12 gigabits per second throughput. What we have seen in terms of numbers for our latencies are typically our 50th percentile latencies are closer to about 200 microseconds, and our 99th percentile latencies are closer to, and I'm talking about smaller payloads, it's closer to about 500 microseconds. So that's kind of the typical performance that we have seen with the service at the higher tiers. But again, it all depends on the workload, the payload that you have. As your payload size increases, obviously, network tends to be a bigger bottleneck than CPU. But on the smaller side, CPU tends to become a bottleneck than network. So it's something that you just have to benchmark and see what works. But this is the kind of the numbers that we are seeing. Okay.
Can you clarify if this is built with Redis itself, or is it something that supports the Redis API?
Can you repeat the question?
Can you clarify if this is built with Redis, like open source Redis, or is it just something that supports the Redis API?
No, so we are built on top of open source Redis. So it's essentially a managed service on top of open source Redis.
And then if I can ask one more, can you elaborate on any changes you've had to make to Redis to make this work?
So that's something that we are considering for the future releases. We haven't made any changes for the V1 version of the release, but as we are looking at different optimizations that we can do, we will look into that in the future. But right now, no.
Hi, thanks. Do you plan to support cross-data region replication? So I'm talking about latency for the end user experience for reads. Right. It doesn't have to be consistent, but do you ever plan to support that?
So we are very curious about the use case for that for Redis, and it's in our roadmap. But we are trying to get a sense of how what that particular use case is in the context of Redis, right? I mean, obviously, data locality obviously is probably one of the main reasons, but I'm curious if you're actually doing that today with Redis in
Yeah, I have a managed Redis on GCP actually provided by IBM, and it's only on the East Coast. So when I deploy to GCP on the West Coast, for example, my servers, the service is noticeably, clearly much slower.
Right.
And all the data transfer is within GCP itself, right? So
correct.
That's the use case.
Okay, so data locality. Okay. We have it in the roadmap. I can't really tell you, by when we will have it, but we have it in the roadmap. Okay. All right, so let me quickly show you the surface area of the product. So can everybody see this, or should I need to zoom up a bit? So we try to keep the product pretty simple in terms of how you provision the service. So if you're familiar with the Cloud Console, you can see memory store. Once we go public, just to be sure that people don't get confused, we are pre-announcing it today, and it'll be publicly available on the 9th. So if you go 9th morning and look at the console, you will see memory store under databases and storage. So that's the new product that you have. In memory store, the provisioning is pretty simple. I can provision a simple Redis instance very quickly. I'm just going to say Redis conf. And today we support version 3.2. We plan to support version 4.0 pretty soon. Quick show of hands, how many people actually require 4.0? Okay, very few. So once you provide the instance ID, you can choose what tier you want to use, right? You can either choose basic, which, like I said, is a standalone instance, and standard, which is a replicated instance. Once you choose your instance or the tier, you can get a sense of what that will cost you. The other aspect of this is the region where you deploy. So like I said earlier, Redis is memory store is a regional service. What that means is that when you deploy a standard tier, you can choose where your master is going to be initially, and you can have the option to say, any for these replica zones, so we will automatically pick the zone for you. But if you want to pick a specific zone that you want to provision the replica, you can do that too. And here, like I said, you can choose any gigabyte you want from 1 to 300. And as you change the slider, you can also get an understanding of the cost that you per hour, or the monthly cost that you will pay for that much gigabyte. Like I mentioned earlier, the pricing is based on gigabyte hour. So for the different tiers, we have different gigabyte hour pricing. But the total monthly cost is based on the provision capacity. How much ever you provision, you multiply it by the unit cost, and times 730, that gives you the monthly cost. We have pricing calculators that's available in our website, so it's easy enough for you to figure out how much the cost is going to be. So this is what I was talking about in terms of throughput. So as you go higher, the network throughput obviously goes higher. So if your workloads are going to be throughput constrained, just make sure that you provision higher throughput or higher size instances. And from a security perspective, we essentially require you to authorize a network. So in your project, if you're in your Google Cloud project, you can have multiple networks. From a security perspective, you have to basically say which network the Redis instance is going to be bound to, and then applications connecting to Redis instance should be on the same VPC network, right? So that's kind of the workflow that you need to go through. The other quick thing that I want to point out is that we haven't exposed a lot of the parameters for Redis, and this is something that we plan to keep a close eye on. We expose the eviction policy that you can set, but we are looking to see whether we need to expose additional Redis configs that people commonly use. We publish the default configs in our documentation, but in case we see a need to add additional configs, we will do that. And then all you have to do is just click create, and that will essentially create the Redis instance. I just want to quickly go into one of the existing instances and show you what you can actually do here. We expose a bunch of the metrics in the console itself, so you can get the time series graph from within the console, and you can get all the property information from the instance details. I mentioned scaling. Scaling, like I said, is pretty easy. You just have to go and change the slider to whatever gigabytes that you want, and we will scale both up and down. The only point about scaling down is that when you scale down, your total memory size should be greater than your current size of the database, right? So if you try to scale it below the memory usage, we will actually fail. And lastly, I just want to quickly show you the integration with the Stackdriver. So we have very good integration with Stackdriver. So we've exposed all the Redis metrics into Stackdriver monitoring. So you can go and look at the different kinds of metrics you want to add. If you want to add new metrics, I don't know why it's not showing. Yeah, we have exposed a lot of the let me do this. Oh, what's going on here? Refresh. Yeah, this mess. I think it's a refresh problem. Yeah, you can add any metrics that you want into the dashboard, and you can monitor your instances from Stackdriver. But if you want to integrate with existing ones, you can do that too. So that's kind of the surface area of the product. So in the interest of time, I just want to move on to the next topic that we wanted to talk about, which is faster insights with Google Cloud and Cloud Memory Store. To talk about that, I'm going to invite Karthi over, who's going to kind of give you an idea how to do this.
Thanks, Gopal. Thank you. Just going to check to see if I can, or if you can hear me. Well, it sounds like it. Thanks, Gopal. So I'm a solutions architect. My name's Karthi Thyagarajan. I'm based out of Dallas, but it's good to be in the Bay Area on this beautiful day. So before we get into the demo, which is going to be the main point of how you do insights with Google Cloud and then also memory store in this case, I want to talk a little bit about our database portfolio and where memory store for Redis fits in. You know, we've had every kind of database that you can imagine, starting on the far right with analytics capabilities with BigQuery, and then in the middle you have OLTP type databases, both relational and non-relational. Within the non-relational, we have document stores, we have key value stores. I mean, these are all services hopefully that you've used and you love. And now we have an in-memory database with Redis. And of course, you know, one of the cool things about that is you get sub-millisecond latency, as you all know. I'm sure most of you have used Redis and know what it's capable of. So that's where Redis, Cloud Memory Store for Redis slots in. All right, so before I get into the demo architecture, I have a survey here. How many of you use Redis today for analytics as opposed to just a database? Things like real-time analytics, stream analytics, things like that. Just see one or two. Surprising because I see a lot of sessions that talk about analytics, and the demo is actually going to focus on analytics. This is something that a lot of our customers have asked for. In fact, today use their own Redis instances on GCP to do this kind of thing. Let me step out of this and actually go to the scenario that we're going to set up. It's a very contrived scenario. I wanted to keep it simple so we can actually talk about what's involved in this mini architecture. So what we have is a credit application processing system that takes credit applications, as you would imagine, and decides to put those applications into different buckets based on attributes that come in. Most of you know that credit score is a big attribute that gets looked at for that. That's in there. And also, another thing that gets looked at in this contrived demo is the IP address of the originating application. So that latter piece is essentially our way of preventing fraud. We have IP ranges that we've deemed are nefarious, and if that originating application falls into that IP range, we are going to deny that application. So the key here is not those attributes themselves. The key here is the fact that we want to do this in a way that is fairly responsive, that is very responsive. When you apply for credit, if you have really good credit and you're not up to some kind of nefarious activity, then to get a good experience, you want to be notified very quickly that you've been approved. So that's what we're optimizing for here. And let's see how we would build this on GCP. One of the guiding principles behind this is using a serverless approach. Once again, that's a buzzword, but it really comes in handy here to be able to do this without having to manage servers, stand up your own instances, that kind of thing. So any kind of stream processing application needs a good messaging layer. And for that, we're going to use Cloud Pub Sub. For those of you who've used Kafka, things of that nature, know what that's for. You need a messaging layer to be able to ingest data at a high rate of speed. And then once you've ingested it, you want to be able to quickly process it. And for this, you may have used things like Storm, Flink, etc. Well, on GCP, you have Dataflow, which is a fully managed service. And a cool thing there is you can actually use the Apache Beam SDK on top of Dataflow. Apache Beam, by the way, uses Dataflow as an engine, but it can also use Flink. It can use IBM Streams. It is truly open source and portable. The architecture is more or less portable if you swap out PubSub for something else. But the important thing here is that it's a serverless architecture. And so let's actually see how this works. I've actually built a very simple dashboard that kind of shows you the applications as they're coming in. And the goal here is you have some kind of administrator that's deciding based on, let's say, the time of the year. If they notice that a lot of applications that are coming in are going into the manual review bucket because the constraints are too high, that administrator should be able to go in and change the credit score threshold so that more of the applications are automatically getting approved instead of having a human look at it. Before I change the threshold, let me just show you that by default, or actually as it is now, when applications come in, more of them are going into the in-review bucket. And that's because the threshold is set to close to 850 here. It's set to 830 or 29. What I want to be able to do is, let's assume that you're getting applications coming in at a rate of a few thousand a second. You want to be able to change the threshold, and hopefully if the demo gods are on my side, we should see more of the applications going from the in-review bucket to the approved bucket automatically. And we want that happening fairly quickly. So in this case, it actually responded, and you can see that the rate of approvals has gone up quite a bit compared to the rate of in-reviews. So that was the demo. So let me talk a little bit about how this is being done. As I mentioned, we are using Redis. This is something that a lot of our customers do today, which is stand up Redis on their own. Having access to this Redis managed service it makes things a whole lot easier. So for one, as Gopal mentioned, you have to put Redis in the same virtual private cloud as your Dataflow instances. Another cool thing, of course, is now you get to use role-based security that's part of Google Cloud to do security, instead of having complex networking constructs to prevent access to that Redis instance. And just from the standpoint of how you actually use Redis, let me just show you a couple of simple things that are happening in this application. In order to look up valid IP ranges, we're using Z-range by score, as well as a separate index. And then also one other thing we're doing, which is also very straightforward, is checking to see if, and this is actually not in here, checking to see if the credit threshold is below a certain value. And both of those things are being done from Dataflow. So quick question, how many people here have used Dataflow or Apache Beam? So one. Another thing that I wanted to mention about Dataflow is the fact that you can do stream analytics and batch analytics with the same code, which is something that a lot of people write separate pieces of code for, and it gets really hard to keep those things in sync. And with that, I'm also going to show you real quick how easy it is to do windowing. And before I show you this code, actually, I want to mention, you can see here that I'm keeping track of counts as applications are coming in. In addition to that, I'm also displaying the rates. This can actually be a little bit of a challenge when you have to do moving averages with sliding windows, tumbling windows, things of that nature. With Dataflow, it becomes really trivial. Right now, Dataflow only supports, or Apache Beam only supports Java for stream processing. And so this is Java code. Essentially, what you have to do is figure out what your window size is. In this case, I've chosen to do a window size of 1 second. You also want to figure out when you want to trigger the firing of the window. Essentially, what that means is, should I wait for 10 seconds after the window closes if you choose a 1 second window before I say the window is closed. All of those semantics for people who are familiar with windowing are built into the API in a fluent manner. So you get to control everything in code. And once that's done, you basically kick off, sorry, I keep switching. Let me go back to the actual command that you run to kick off your Dataflow job. Make this a little bigger. This is essentially integrated with Maven. A couple of things I'm going to point out are the fact that the network is the same as the network that the Redis instance was spun up in. You also have the ability to specify the subnet if you so choose. And once that's issued from the command line, what you'll notice is Wrong one. What you'll notice is this really cool looking pipeline that looks kind of complicated, but the key here is you get to pictorially see what your pipeline looks like instead of having to deal with machines. If you care about machines and what your usage is and things of that nature, Dataflow will show that to you. So anyway, like the takeaway here with this demo is when you marry Dataflow with Redis, you get the ability to do really cool analytics while sharing state across your Dataflow instances, which is not something that you could do before without sacrificing latency. The sub-millisecond latency that Redis gives you, combine that with Dataflow, it opens up a whole new way of doing stream analytics in a fully serverless fashion. So I'll stop there. Looks like I'm out of time.
Thank you.
Just want to quickly mention, if you have more questions, please feel free to come to the booth. And just want to say that we are actually doing a UX research. So if anybody's interested to participate in the UX research, you get a $125 gift card, but you get to participate in terms of the future enhancements that we want to make. So just wanted to call that out. And also please visit the website if you need more information. Thank you very much. Thanks for attending.
Thank you.